Yeah, good afternoon, everyone. Uh, Thank you, sir, for giving this opportunity, especially NHAI. The topic is on a soil stabilization. The soil stabilization is a very old topic. I think since last 30 years, people are stabilizing the subgrade and subbase and base layers. So nothing is in the part, recent days, people are coming with the FDR, full depth reclamation. So let's say these days in the many state roads, rural roads, national highways, for every 5 years or for every 4 years, frequently they're putting overlays. So basically they're not looking where the damage is, simply on above the cracks they're putting an overlay. So it's within a short period, the cracks are going to reflect, the pavement is going to damage. Some cases what they're doing, they're milling up to a certain depth and they're putting in an overlay, but still the cracks are going to reflect it. So the best way is whenever the distress are up to bottom levels, let's say your base is damaged, including your asphalt, the best way is FDR. So at in situ itself, at the, let's say the same material, you can reuse it and you can recycle it. So FDR involves a recycling of existing bituminous pavement and underlying pavement layers into a new base layer. Basically, it excavates and pulverizes the material with the addition of cement, water, or any additional aggregates are required. So basically, so whenever you had damages, especially up to base layers, the FDR is the best suitable method. So benefit is almost, you can say, around 30 to 60% of in cost. It depends on how much length you are rehabilitating. The payment condition improvement, it's a long life payment. The load carrying capacity is very high when compared to conventional payments. The modulus of that layer is significantly higher than the conventional payment. Coming to environmental benefits, you can use in situ materials. You can save a lot of material, and it's a least cost alternative. Very thinner surface are required. Let's say if you go very on a poor subgrade soils, so in that cases we have to go very high thick asphalt layers. Instead of that, if you go FDR, full depth recycling, since that case very thin asphalt layers are required. Now type of binders for FDR. So many type of binders are available. Cement, emulsion, foam bitumen, fly ash, lime, and other some commercial chemical stabilizers. So these binders can be adopted singly or in a combination. So because let's say in the most cases these people are going with cement, it's a very low cost and a very high strength gain. So when compared to other binders, cement is economically and getting more benefits. Now which roads are suitable for FDR? So whenever you have damages or up to the base level, let's say you have your damage on top surface layer, then it's not a suitable method. Simply you can mill it and you can overlay it. So whenever your damages are up to the base or sub-base layer, so in such cases, instead of taking out the material, you can reuse the same material and make a strong base layer. On above that, we are going to put a single bituminous layer. If the traffic is very high, in such cases we can go DBM and BC. If the traffic is very low, single BC layer is sufficient. So a lot of energy saving and material saving in terms of material, number of trucks, landfill, fuel cost, all these are going to save in a significantly higher amount. Now let's say how to do it. So in FDR, the depth of recycling depends upon your distress levels. Let's say if your pavement is distress up to 200 mm, then for that material you have to collect it in the field, take to laboratory, and we have to do the mixed design. So that the depth of recycling depends upon your distress levels. So you have to go to site, you have to see up to at what level distress levels are there. So up to that point, we have to collect the material and we have to do the mixed design. So in the laboratory, let's say if you're going with the cement, we have to do the UCS test and durability test. Based on these two parameters, so we have to decide, we have to do the mixed design, what is the optimal amount of water content, optimal amount of cement content. So based on UCS and durability, we have to decide the cement percentage. So the mixed design for FDR process, determine the suitable percent of cement and water to be admixed before the compaction. That's the mixed design part that we have to carry it in the laboratory. And pulverized pavement sample will meet the gradation. Sometimes, if you don't have right composition of the pavement, there is shortage of some aggregates. So in such cases, we need to add some fresh aggregates to meet the target gradation. So gradation for pulverized pavement, these are the gradation right now what we have the stabilized for the CTB as per IRC 37 Murth. But if you follow this gradation, this most of the payments, sometimes it won't fit in the gradation. So this is a gradation the Portland Cement Association following. So in such cases, the most of payments are going to fit for this gradation, and it's going to satisfy the performance also. So this is a mixed design part. We have to find out what is the optimum cement content. So we have to see at different cement contents what is our UCS values. So we have some target UCS value. So at what cement content we're getting that my target UCS value. So based on that we have to fix the cement content. At that cement content we have to check the durability test also. If it is not satisfying, you have to slightly add some cement content. So basically this is a construction sequence. You can see the first is a cement spreader. Let's say if you have any shortage of aggregates, we have to spread some amount of aggregates also. So it is attached with the water tanker, attached to recycler. So it is going to cut your required depth. The depth depends upon your distress levels that you have to decide during the investigation. So it's going to cut to required depth. So it is going to mix existing material, if required any fresh aggregates, cement, water, and after that followed by compaction. So this is a sequence of construction. The main advantage is the same metal you can reuse it. Almost 85 to 90% metal you can reuse it. This is a construction process. This is already explained you. That's if any shortage of material, you have to put some aggregates of soil, cement spreading. If let's say these days there are a lot of additives are there. Each additive has some unique advantage. So based on the requirement, we have to select the additive. So next it's a recycling followed by compaction. So let's say after it's a high amount of cement, around 4 to 5% cement. There are high chances of shrinkage cracks will take place. So to avoid those cracks in the top surface, we have to put in a SAMI layer. It's a crack relief layer. So these cracks won't propagate to the top bituminous layer. Followed by prime coat. On above that depend upon traffic and soil conditions, whether you have to go DBM, BC or BC. So the quality control aspects during DPR preparation. So we have to see what is existing pavement subgrade and other pavement layers. So mixed design to be adopted for FDR. What cement type of you are using, but the same type you have to use in laboratory also. During construction process, pulverization of pavement layers and right placement of right moisture content, quantity of cement spread on the pavement, uniformity of cement mixing, layer thickness after compaction. Let's say we are targeting for 250 300 mm, whether you're getting the right thickness or not, we have to check it. In situ compacted density, the compressive strength of a cement admixture cube molds. The same after construction, we have to take a course and we have to check the strength, we're getting a target strength or not. So I think in 2018, we started some project. We evaluated 3 roads, how would this FDR payments are behaving with time. So test sections were constructed in year of 2017-18. So performance evaluation of these pavement structures are being monitored for 3 years. The roads are especially all in southern region, Krishnapatnam Port, Poranki in Vijayawada, Hyderabad. So these are stabilized with a cement and additive called stable load stabilizer. So these are the details of the pavement. Different trial sections they laid. They recycled 300 mm, few sections they recycled 400 mm. So similarly to Hyderabad also for this in outer NTR mark. So basically, so they constructed and we observed how it is behaving with time. We took the course and we did some non-tested analysis also. So we found that with time there is no decrease in the strength values. So it is maintained the required target usage values that we observed in all type of the roads, all our studied roads, all are above the limits. So these are the field core samples extracted from the field. You can see it contains a different composition. Why? Because some pavement contains a WBM, WMM, some pavement contains GSB and asphalt. The texture looks depends upon the what type of pavement you are recycling. So we check the durability also. So all are within the limits, within the time also. The durability is slightly reduced, but still all are within the limits. Similarly, we conducted the non-destructive study using FWD. So we compared with the conventional pavement and the stabilized pavement. You can see clearly the modulus value for the stabilized is significantly higher when compared to conventional asphalt layer. Here the asphalt layer thickness is very low because that pavement is badly cracked. Okay, so almost we're getting some 6,000 to 7,000. So with time also there is no change, there is no decrease in fall in the modulus value for all the type of the roads. The modulus values, most of them all above the 6,000. So in the design, people are considering 5,000 modulus value, but still the value after 42 months also, we are getting high significant modulus values. Similarly, we evaluated some roads in Andaman Nicobar Islands, where because there is a lot of shortage of aggregates. So in such locations, it's very useful technology. With the same material, you can reuse it. The same material can reuse it because you need to get aggregates from the mainland. So it's very difficult, very costly business. In such locations, you can reuse the same material and compact it. So the main concern is, the main thing is design usage value. So most of as per IRC SP 89, our target usage is 4.5, 7 days usage value. So different agencies have different opinions. According to ARRA, we should not cross more than 5.5 MPa, 7 day usage strength. Many agencies, many Department of Transportations, they're targeting 70 usage less than 4.5. Why? Because this is an issue. If someone is over ambitious, if they are targeting for very high usage value, okay, you make it a very, very high good strength, but the issue is you may find a shrinkage cracks. Such type of roads, the cracks are distance in between the 4.5 meter, 5 meters. If I am taking core in between that, I am getting very high usage value, 7 MPa, 8 MPa. But the issue is, if they are targeting for very high usage values, we are going to see such kind of shrinkage cracks. So we have to be very careful. It should not be very high, it should not be very, very less. Similarly, we observe other pavement also. So whenever here they stabilize the soil layer, here they stabilize the asphalt layer. In asphalt layer also, if they are targeting very high UCS values, you're going to find such type of shrinkage full depth cracks. So you have to be very careful while doing the mixed design. So this is an ongoing work. The package at Andaman, the work is presently going on. So we submitted the mixed design. So based on we went to site, we check the distress levels. So based on distress levels, based on traffic, so we considered how much depth we have to recycle it and how much amount of cement and what is required. The presently work is going on. Basically, the advantage is conserves the energy, it conserves the materials, long-term cost effective, environmentally desirable, and maintenance cost will reduce significantly. So the main take is, so whenever you found a distress payments, okay, first you have to investigate if your distress levels are on the base or sub-base layers, the FDR is the best suitable option. So in that case, the same material you can reuse it. On above that, very thin asphalt layers are sufficient. So presently, guidelines are under preparation. Guidelines for a full depth reclamation of payments for national highways. For traffic is more than 2 MSA, up to 100 MSA. So within a 1.5 months, we get a guidelines.